All right, guys, welcome to JJ Concepts Rapid Engineering. And you might be asking yourself, what the heck is this thing on my screen? Well, this is something that I created from my head, out of nothing. It's not that hard. There's some best practices that make it go a lot smoother. And so I'm going to go through and kind of show you guys my process for how I do physical part design, assembly design. It's a crash course. This is not a SolidWorks tutorial. This is a conceptual design example for you inventors, engineers, DIYers, and pretty much anybody who's designing physical things, especially in CAD. The same concept can be applied to other formats, such as drawing on a napkin, but it's really meant for CAD because CAD lets you do things so much quicker and more explicitly than you can in any other format. So, all right, well, let's get to it. So, first of all, what is this? Well, this is just a recording mount for the other types of recordings that I do. These right here are just half-inch Schedule 40 PVC. I have a frame already built, and I want to be able to hold my phone in a centered position. And these, I didn't model everything, but these are basically LED mounts. So let me show you the outline of those real quick. Where'd they go? There they are. Yeah, so that's basically how big. They're panel lights that give diffuse, non spotlight type of light that gives off a bunch of glare. So that's the point of this. That's what I'm doing. So let's start from the beginning and show you the history in this CAD file of exactly how I arrived at this, because it's pretty methodical at this point. 12 years, well, if you include college, more, that I've been doing this. And at this point, I pretty much have a process down that puts my creativity into a nice little controlled package. So to save time and to make designs better in the long run. So let's go through that. All right, so this is what you start with makes so much difference. And so I know I'm going to use my phone for recording. So why don't I go ahead and start with what I know? That's my phone. And I can move it up and down with various tricks if I want to, but I know I want my phone to be on there. So why don't I start with that information? Then next thing, I know I want the LEDs to be there. They have a specific kind of camera mount. I know roughly where I want them to be in relation to the phone. Again, the mount doesn't matter right now. The mount is what's going to allow me to accomplish these objectives. So I don't need to start drawing the mount yet. I need to start drawing the requirements that the mount needs to adhere to. So I can just suspend them in space. It's the beauty of virtual design. So that's basically everything now. I didn't go, if it's something that's complicated to model, I don't waste time doing it. I just model the dimensions that matter. So in this case, this is a sketch for those of you who aren't that familiar with CAD. Oh, wrong sketch. Where's it at? LED panels. I named it. Maybe if I just look at my damn labels. So that's all I did. Got that with calipers straight off of the parts that I ordered from Amazon. So haven't even begun, and you can see I have a non-negligible amount of work in my feature tree. Of course, it's fairly quick. The more you use whatever particular platform you use, whether it's SolidWorks, AutoCAD, or Solid Edge, or I'm probably missing a couple of big names right now, but anyway, I'm using SolidWorks and I'm pretty fast at it. So this really doesn't amount to a lot of time, and it means that whatever I do from here on out, it can't be wrong unless my assumptions are wrong. And basically, the location of these things, these are all my assumptions, and so now I've limited my creativity to only those things that accomplish the specific goal that I'm trying to accomplish, as opposed to if you go in there and just start drawing, the geometry that you think you want, then when you got it wrong because you kind of jumped into it too quickly, it's really hard to go back and make changes. But if you have your assumptions modeled in there, then you can, right high up in the tree that doesn't hurt farther down in your tree, you can go and make changes. And most of the time, your geometry all down here will automatically update to your changes. So if I just wanted to, I wanted to move my phone a little bit lower in relation to the, see, now it's not as high up above the scaffolding that I have. But so let's just I'll show you the difference real quick. See, it's that easy. And there'll be some minor errors, but basically if you use this geometry to create the geometry of your part, then it probably won't get confused or very confused. You only have to change some errors. Again, this is specific to CAD and how virtual design software works, which is a major consideration, obviously, if you're using it. So, but let's go on to the first features. Oh, I wasn't quite done. Those are some the tightening nuts, basically, for this specific type of camera mount, which matter, obviously, because I can't, if I tried to model the phone, if I didn't model those, then I'd be putting the phone somewhere down here, and then the parts that I have wouldn't even fit, and I'd have to start all over again and make this is specifically designed for 3D printing, so that's the manufacturing process. Normally the manufacturing process is you have to really, really take that into account. That is, that's probably the biggest thing to take into account when you're doing conceptual mechanical part design, is you have to have the manufacturer, like an intimate familiarity with the manufacturing processes, so not to make geometry that's not possible to make. But the beautiful thing about 3D printing is there's really no geometry that it can't make. I mean, it depends on how easy you want it to be, which also becomes an art in and of itself, is designing things for ease of 3D printing. But there's not a whole lot of limitations there. It's just about how easy you want it to be. So some more sketches that turned out to be, let's see. Yep, there. Okay, so that I have started to draw the actual part that I want to print. That's why it's in gray and not blue. So you might say, well, that's a weird way to start. Well, so I've divided this part up into quadrants, basically, because I know I'm intending it to be symmetric about this axis and about this axis. So instead of drawing all this detail, 2 or 4 times, I'm just going to draw it once and then mirror it over to here and then mirror it over to here. So I already have that plan in mind, so I know I don't have to waste time drawing stuff that I'm just going to duplicate. So I just, what did I do? Okay, so then I put the floor. So that's the body of it, the basic body of it, with the mount in there. I know that I want that to be there. And then I put a floor in so it can't fall out. And then, again, this is another kind of possibly non-intuitive way of going about it. You would have thought that I would have drawn some kind of support to connect these things first, but why? I know that I have this requirement here, so why don't I go ahead and just put that geometry in? Again, the beauty of virtual design, you can just suspend things in midair. You don't have to work from the outside in or from the top down. You can work from a conceptual logic tree or a logic. You can work from the basics and build from there. So you build a logical tree as opposed to having to worry about physical constraints. So I know I want that to be there because I want the part to rest on the PVC supports. Then now I make a connection, and I just decided, well, let's that looks like plenty of support. And then how thick should it be? It's going to be 3D printed. It's going to have maybe 20-30% fill, so the density of the material is actually 20 or 30% less dense than than if it was a solid, like injection molded part or board or something like that. So yeah, I'm gonna make it 1/2 inch. It's really easy to make stuff strong that has wide walls. So if you have the ability to hollow something out, you would never not make something bigger, as big as you possibly can, or as thick as you possibly can, because the outer skin of a part is basically where the majority of the load bearing capability comes from. Take, for example, a drive shaft. A drive shaft can handle the torque of a Cummins Duramax diesel, make 2,000 foot-pounds, with a wall thickness of, like, I want to say it's probably less than 1/8 of an inch, just because they make it hollow and they make the diameter really, really big. And so it doesn't they spread out that torque on the outer skin. And in 3D printing is very similar to that it's the magical ability of technology that you can choose the infill and even the pattern that goes on inside this cross section. If I was to make a cross section of this part and it was 3D printed, you would see all the overlapping cavities and whatnot. So thickness is not your enemy in 3D printing. Thickness is very much your enemy in almost every other form of manufacturing, particularly tooled manufacturing, like casting and injection molding. So a little bit of a sidebar there, but again, these are all things that go on in my head as I'm designing that just have become second nature because I did them for so long. So then there's the middle support. Notice it's half the thickness because I'm going to mirror about this axis, so I don't need it to be. I want it to be the same thickness when I'm done. Went ahead. This is a kind of a weird way of doing this, but it's the one I thought that would be the most robust from a CAD modeling standpoint. If I change the design, I know this won't ever change. This is a surface. I just inserted a surface. It has zero effective thickness, really. It's just a virtual again, something you can only do in virtual design. That it's just a virtual infinitely thin surface, and that is basically the camera. The camera on the phone is right there, and that's a viewing angle. You notice there's still something blocking it. That's a little tool we're going to use later. So let's go down. Let's do so what's that? Okay, so that was, you can see, so I modeled, how thick I thought it needed to be. Really, in retrospect, I could have just modeled this up to here from the beginning. I know that I want to support the phone anyway, so why don't I just do that way over here in this thing? But I did, a lot of times you don't, the limitations of your own mind, you don't become aware of things until it's glaring, further on in the design. So, a little not the best conceptual design, because technically I knew that information up here in the tree, and so I didn't need to wait to put that in there. There was no reason to, but nobody's perfect. So now I know that I want the phone to be constrained and aligned, so that I'm not taking a crooked picture. It's repeatable every time I put it in there. So nice big lip there for the phone, and then I'm not sure why I did that after, put the surface up here and then did it up here, but there's a lot of freedom in virtual design and where you put things. You get the same result. But so far, the only inefficiency that I see in my process here was really that one I just mentioned, with that feature that extended up to here. I could have removed that feature, but so far I haven't wasted much time in making this. It's very straight to the point. I didn't have to make a bunch of bosses on top of bosses on top of bosses, because again, I have all my information already out here. Why would I make a feature that could be one feature or two features by using 5 features or 6 features? If I already know the information, then just go straight to the end. All right, and then that cut, let's see, what is that? Oh, that's just a little, I don't want, if it's tight, I don't want to have to be pounding that camera mount all the way down through these little, 3D prints tend to be inflated a little bit or oversized by, holes are smaller, bosses are bigger, and so I try to account for that. 5 to 10 thou. It depends on the layer thickness and the material and the printer and whatnot, but I try to account for it. But I still don't want, like, that material is really not doing anything for me being there anyway. So if it does turn out that the 3D print is snug, then why would I bother having to force this thing down through all of this T slot? Just get rid of it. Make life easier on myself. All right, now we are to the fun part, which is where you get to make it look sexy. Again, the part would work just fine looking like this. Again, this is just 1/4. So let me see. Close your eyes. Close your eyes. Don't watch. You don't look at the. You can't see this till the end. Don't look. Wait. Okay. So this is what the part could look like. You can open your eyes now, by the way. This is what the part could look like. It'd be perfectly fine. There's nothing wrong with it. It's not like it's carrying a heavy load, but I just can't help myself. I have to make things look sexy. It's half the fun of having a virtual, powerful software like this is you can just make things look sexy in a matter of seconds. So, all right, now you can see the stuff that I'm sure you didn't see because you had your eyes closed. Unsuppressed. Let's go. Let's just work our way down. That's an obvious, if I was designing this to make it, carry a big load, that's an obvious failure point right there. A, it's a sharp edge, which is just a place that cracks can propagate. And then B, it's, the load this is the support. The support surface is right here. And so that the stress on this part is just getting bigger and bigger and bigger. So why would I want this thing to be the same height all the way out? It has low stress here and high stress here, and so that's just a bad design. I'm probably wasting material here, and I don't have enough material here. So I could make it equally strong based off of the load profile. Again, let's look at it. This is a quick little statics lesson. The load is being applied right down here, right there. That's a quick little arrow. That's where the load is, and this is where the support is. So the material here is doing very little, and then the farther you get, the closer you get to the load, the farther away from the support you get, the more load that the local material is having to take. So something that makes it look sexy and solves that problem. Nope, not that one. That one. Boom. Then there's no weak point in this now. Like, if it breaks, it's just going to be the bulk strength of the material is not sufficient. It won't have any weak points in it. Again, mostly doesn't matter for the purposes of this part, but why not? That's all going to be hollow anyway, so it's not like it's even using that much more material. So, and then just some of this, again, purely aesthetic. That versus that. Boom, boom. All right, what do we got there? Yep, couldn't have those sharp edges. And again, another thing to take into consideration, I will not be filleting these surfaces. Why? Because that's the build plate surface. So the more contact that you have in general with the build surface on a 3D print, the better, the more robust the print is, the less likelihood it has of messing up, coming unstuck. You can go overboard, and if you have too much area, then it'll actually warp the print. But I don't think this one's is in danger of doing it with this big open space that I have here. So not putting any fillets there, and fillets are easy to make as long as they're on the upper or side build surfaces. of a 3D print. And then I'll just skip through these, and they're not too consequential. And then, boom, let's make it look pretty. Let's make it look pretty. Yeah, real view, and oh, look at that. Look at that. And then, so that's it kind of in use. Oh, and then I did add these holes. After the fact, just thought about it for putting a little screw into to stop the phone, so I can have the phone be either of this orientation or over here on that orientation. And the holes, then if I put a screw in here, it'll bump up against this one in this configuration, and then if I put one right here, then it'll bump up against that one in the opposite configuration. So that's why I put that there. But there it is. And then let me remove the parts that will not be printed, and boom, there it is. Let's get rid of that surface too. That's annoying. Yeah, there we go. There is the beauty that is a part that will never need to do anything important. But it was fun. It was fun, and it's cool to me. It's cool to make to design things that based off of requirements, and it's kind of fun, the challenge of meeting those requirements in an efficient and functional manner. And also, most importantly, what this whole video is about is not taking a lot of time to do it. Doing it in a way that maximizes your time and your value, both for your own time, for your own purposes, or in a professional capacity, for a company you work for or whatnot. Then doing a good job quickly is obviously better than the alternative. So hope you guys found this interesting. If you're nerds like me about stuff like this, maybe you did, maybe you didn't. Let me know. Might not be your cup of tea. This is the first time I'm doing this on my channel, this type of content. But let me know. If you hate it, think it's stupid, can't use it, tear more tools down, show me the insides of more tools, whatever. Let me know. It ain't gonna hurt my feelings. Well, it might, but I won't tell you about it if it does. So anyway, like, share, subscribe if you really like the content, or if you like what might come in the future. Thanks, guys.